Hello, Geometry Honors. Welcome to 13.6, Day 2, more practice with circles. So I am going to actually ask you to pause this video for about 3 minutes so that you can have a chance to try problem number 6 with your teams. All right, now that you had a chance to try it, let's find out how you did. So a picture is not mandatory, but I think it can really help. We can use that little trick on Notability where you can make a perfect circle. All right, a couple things. Based on what you learned yesterday, you do know that the center of this circle is -1, +5. We are going to be finding the equation of a tangent line at the point -6, 17. So we're doing lots of review here. Tangent lines was from chapter 10. Equation of lines we did in chapter 13.2. And then the equation of the circle was from 13.6. So all this extra semester review, what could get more exciting than this? So here's the point, -6, 17. And let's try to make a nice tangent line. It's a little crooked, but it's going to be just fine. All right, a couple things. We do know from chapter 10, radius is perpendicular to the tangent at the point of tangency. One quick review that we don't need for this problem, you do know from yesterday, the radius of the circle is 13, but we don't actually, that's not going to be used here, but just wanted to review that really quick. All right, so now quick reminder from 13.2. For the equation of a line, we need a point and a slope. Well, we definitely already have a point on the line, but right now we don't know the slope of the purple line, and we only have 1 point on the purple line. So what we're going to do instead is find the slope of the radius, because we do know the 2 points on the radius. So the slope formula, which was lesson 4.6. So we have y minus y over x minus x. So we have 12 over 6 plus -6 plus 1 is -5. But we need the perpendicular slope, which was our purple. So we need the slope of the tangent. And sometimes I don't want to write the whole word tangent. I just do I just write perpendicular slope, and that's going to be +5 over 12. And so now there is our slope. There is the point. You know what's going to happen. We're doing point slope. Y minus 17 equals slope of 5/12 times x plus 6. And that is that. Awesome review. Awesome to connect so many different ideas. I hope you enjoyed that one. I'm sure you'll see it again soon. All right, next, here's a theorem from lesson 10.1. We've never, ever used this theorem until today. I know you're going to be so excited. It's going to be awesome. The perpendicular bisector of a chord passes through the center of the circle. Now you're wondering, how are we going to do that? How is it going to help us? Let's find out. All right, so the way we're going to use it, actually, I already gave the hint because in case you were doing these problems totally on your own. But the center of the circle is the point of intersection of all of those perpendicular bisectors. So I think a picture is super helpful on this problem. So whatever color you like, go ahead and make a circle. All right. We don't have to be perfect, but we want to be halfway decent. So let's plot our points 2, 7, 8, 7, 9, 0 would be somewhere to the right and down from there. Now, so we actually could draw 1, 2, 3 different chords, but we don't need all 3. So you can pick any 2 chords that you want. This one is really nice to pick because it's a perfectly horizontal line, so that can make our work easier for us. And I actually like doing this one right here, just because it's not going to be in the way when we do the next step. But if you really wanted to, you could choose the 2, 7 and the 9, 0 and have that chord as well. All right, so now what are we going to do? We need the perpendicular bisectors of these two chords. So I think what I'll do is I'll pick a different color for each one. And I was trying to make it perfect, but my pen glitched, and so that's what we get. But it's perpendicular and it's bisecting. And then we're going to do it for our other chord. Again, it's not going to make it perfect because I see some glitches in my line. But wherever those two cross would be the center of our circle. Here, I'll put my perpendicular down here. Put my tick marks for bisecting here. Another thing that's not mandatory, but it'll definitely make it easier to do the work and to talk about. I'm just going to go ahead and letter my points A, B, C. And that'll make the next steps just a little more efficient. So I'm actually going to encourage you to pause the video for about 2 minutes so that you can find the equation of the green line and the equation of the purple line. So just like we did in lesson 13.2, write the equations of those perpendicular bisectors. So take about 2 minutes and then come back and we'll keep moving forward. All right, here we go. So my green line is the perpendicular bisector of segment AB. And so a couple nice things there. We need the midpoint. So 2 plus 8 is 10. Divided by 2 is 5. Do I have room to write that? I think I can fit it on here fine. So that's 5. And then the y value doesn't change. That's going to be 7. So we have the midpoint of 5 comma 7. And normally we would find the slope next, but we know that our segment AB is horizontal, which means our green perpendicular bisector is vertical. And we know from lesson 13.2 that all of our vertical lines are x equals, and then the x coordinate. I think I need to move this a little bit out of the way. We'll see. And now we do need the perpendicular bisector of the purple line. So the purple perpendicular bisector of segment BC. And so we need a point and a slope so we can get the midpoint. 8 plus 9 is 17, so the gorgeous number of 17 halves. 7 plus 0 is 7 divided by 2, so 7 halves. You could make that a decimal if you want to. I'm going to encourage you, don't be scared of fractions. They're going to keep showing up. All right, and we could label that. We don't have to. If you want to, you can. Okay, now we do need the slope of, we want the purple slope, but we can't get it yet. So we do have to start with the slope of BC. So 0 minus 7 and 9 minus 8. So that was pretty quick and not too painful. And then we need our perpendicular slope. So finally we got the slope of the purple line. And that'll be the opposite reciprocal of positive 1/7. And so then our equation of the purple line, we can use point slope y minus 7 halves equals the slope times x minus 17 halves. Now it is possible to write that in slope-intercept form. Depending on what you do next, you may or may not want to do that. It is definitely not mandatory. So now we are trying to find this center point of the circle, which is where those two lines cross. So I'm going to encourage you to pause the video again for about 2 minutes and solve your system of equations. So we want to know, where does this green line cross this purple line? So you can solve with substitution or elimination. I hope you know which method's going to be a little more efficient. But again, take 2 minutes, solve your system, and see what happens. All right, let's do some algebra and see how it went for you. So I hope you chose to do substitution because we can just put the 5 in for the x. So y minus 7/2 equals 1/7 times 5 minus 17/2. I'm going to zoom in just so I can see it better and try to write nice enough that you can read it. And this way, hopefully, you can see it better too. So we do a 5 minus. Maybe I'll switch colors to each step. That should help out a little bit. So, okay, nothing happening there yet. Nothing happening there. So 5 is 10 over 2. And so 10 take away 17 is -7. And now we can multiply on the right-hand side over there. And that actually, not too bad, turns into a -1/2. And so now when we do -1/2 plus 7/2, we get 6/2, which is just 3. And keep in mind, we already knew the x-coordinate was a +5. So here, let's go back to our picture. You don't have to, but you could write down that we just found those coordinates were 5, 3. Now, we are trying to write the equation of the blue circle. And so we found the center. We still need the radius. So it's your choice. We could go here, or here, or here. So you go ahead, pick any of those 3 points to do the distance formula. So I think I can fit that right over here. So I'm going to go ahead and choose 9, 0. And so then we have 5 take away 9 squared and 3 take away 0 squared. And it's going to be some numbers you've seen before. It's another 3, 4, 5 triangle. 16 plus 9 gives you the 25. And the square root is a 5. And so now that we know the center and we know the radius, let's see, what color haven't I used? Where can we fit it? Maybe we could go just really dark purple over here. So we have x minus 5 squared plus y minus 3 squared equals 25. So lots of work, lots of great math, lots of review, and a little bit fun too, I hope. All right, well, thanks for following along. I hope you understand all these steps. If not, please reach out to get some help. So right now with your teams, there are problems 8, 9, and 10. You're going to be so excited. Number 8 is going to combine 13,4 with 13,6. And then number 9, you already practiced yesterday. And then number 10 is one more time to complete the square. And you can check your answers on Schoology. And once you get all 3 of these correct, you can go ahead and work on the homework. Don't forget to work on your photo project a little bit. Just do anything you can to move forward on that. And I hope you have an awesome rest of the day. And I'll see you soon. Bye.